Hi, I'm Andy and this is question 5 on the AQA Decision 1 paper from January 2010. For more questions on this exam paper, click the eye in the top right corner. In question 5, we're told there's a one-way system and Mia is parked at her base B. She intends to visit 4 other places, A, C, D, E, before returning to her base. And the following table shows the distance in kilometres for Mia to drive between the 5 places. Notice in the table that there's a from and a to. So if you want to go from A, for example, to D, you would have to find A in here and go across until you get to D at 1.8 here, which is different to if you went down the table here, which gives you 2 look. In part A, it says find the length of the tour BEC DAB. So following the table, we need to go from B to E. So make sure you're starting in the from column. So B to E would give us 3.7. E to C would give us 1.9. C to D would give us 2.7. D to A would give us 2.0. And A to B would give us 1.7. And that gives us a total length of 12. In part B, it says find the length of the tour obtained by using the nearest neighbour algorithm starting at B. So if we start at B, remember to look down this column and go across rather than working down like you might normally do. The closest place we can find to B is D at 1.8. So we'll go from B to D first. It's a good idea to write down the values as you go along so you don't have to do the whole thing twice. Now we're at D, we'll go across. The nearest place to D would be A at 2.0. From A, the least value in the table is 1.7 at B, but we can't go back to B yet, we've got to go everywhere else first. So the next shortest, D, we also can't go there. So we carry on, and C is the next shortest, so we'll go to C, which is plus 1.9. From C, the only place we haven't been yet is E. So we need to go to E, even though it's the largest at 4.2. And finally, we need to go back to the start, which is B. So E to B is plus 3.6. And that gives us 13.5. In part C, it says write down which of your answers to parts A and B would be a better upper bound for the total distance Mia travels. Well, an upper bound is a possible solution to the problem, and the better upper bound is the better solution to the problem. In this case, it will be the route that has the shortest length. So the 12 kilometres is a better upper bound than the 13.5 kilometres. In part D, it says on a particular day, the council decides to reverse the one-way system. For this day, find the length of the tour obtained by using the nearest neighbour algorithm starting at B. So this time, rather than going across, we're going to go down the columns. So starting from B, if we go down this column, the shortest route we can go to is A. So we're going to go from B to A, which is 1.7. From A, the nearest place is D at 2.0. From D, we could go to E, which is 1.7. From E, the only place we haven't been to is C, which is 4.2. Even though that's the largest, we have to go there because we've got to visit every place. And then finally, from C, we need to go back to B, which is 2.5. And that gives us a length of 12.1.